am Desiree Bermeo, and today I will be discussing the assigned topic to me, which is the inductive and deductive reasoning. There is one logic exercise we do nearly every day, though we're scarcely aware of it. We take tiny things we've seen or read and draw general principles from them, or an act known as reasoning. Now, we will be talking about the two common types of reasoning in mathematics. This form of reasoning plays an important role in mathematics in our modern world. Before we officially start, let me first tell you the aim or objectives of this discussion. We will know about the two common types of reasoning, which is the inductive and deductive reasoning. We will also talk about differences between the two, and we will use inductive and deductive reasoning in every exercises. 10-item test will also be given right after the discussion. This is part of the presentation that will enable us to test how well we understand the topic. So what is reasoning and how to apply it in mathematics? Reasoning is the action that we do whenever we want to think or say something in a logical or sensible way. Reasoning is often a highlighted topic in various fields like philosophy, science, language, and even in mathematics. What is reasoning in regards to mathematics or mathematical reasoning? Mathematical reasoning is a critical thinking skills that enable someone to make use of all other skills in mathematics. Again, there are two common types of reasoning, and these are the inductive and deductive reasoning. As of the moment, as you can see, I am holding a pouch right now, and I want to get things out of here. So here's what I've got. I get the first thing, and it's a ball pen. Okay, let's have something else. Again, I've got another ball pen. Awesome. I'm going to take another thing out. And yes, it's still a ball pen. If you were to guess what I'm going to pull out next, and if you're going to say ball pen, then you're totally correct. This simply means that inductive reasoning is the process of gathering specific information, usually through observation and measurement, and then making a conjecture based on the gathered information. For example, yesterday morning, Isa went jogging. This morning, she jogged again. Therefore, Isa will probably jog tomorrow morning. This conclusion is not definite, but based on the morning routine of Isa, there is a high chance that she will jog tomorrow morning, right? So supply the missing term. The first given is 2, 4, 6, 8, and as you can see, they are even numbers. As we try to observe, we are just adding 2 in each number. Okay, so when we skip counting by 2, 10 will be the answer in the first given. Therefore, you can get the answers by observing the sequence of numbers. The next and the last pattern is 1 plus 1, 2 plus 1, 3 plus 2, and just simply add 3 to 5. So the answer is 8. So this is what we call Fibonacci sequence. This is another example of inductive reasoning in using visual patterns. As you can see first, there are only 3 pentagons, a 5-sided polygon. We can notice that the inside of each pentagon has a ray. Every ray changes its place inside. Therefore, as we are to guess the next figure, we can only determine where the next arrowhead will be by observing the other 3. The following are the key ideas of inductive reasoning. So the next one is the deductive reasoning. This is a process of reaching a conclusion by applying general ideas called premises. This concept often expressed visually using a funnel that narrows a general ideas into its specific conclusion. Recognized rules, laws, theories, and other widely accepted truths are used to prove that a conclusion is right. The most common form of deductive reasoning is the syllogism, where two premises that shares some ideas that support a conclusion. This one is also similar to transitivity property of equality, where if we have A equals to B as our premise and B equals C as another premise, then A equals C because both are equal to B. For example, all men are mortal. Ram is a man. Therefore, Ram is mortal. In symbols, let this B implies C, and this one A implies B. So we can see here that B are the same. So A implies C. The following are examples of deductive reasoning. How about this example? All musical instruments make sounds. Jeepneys make sounds. Therefore, jeepneys are musical instruments. But wait. All musical instruments make sounds. This is a true premise. Jeepneys make sound. This is also a true premise. But jeepneys are not musical instruments. So this is false. Therefore, this is not a valid deductive reasoning. Always remember that we use premises to prove the conclusion is true and not to justify it. Deductive reasoning is meant to demonstrate that the conclusion is absolutely true based on the logic of the premises. So everyone, the following are the key ideas of deductive reasoning. So what are the differences between inductive and deductive reasoning? Inductive reasoning uses patterns and observations to draw conclusions, and it's much like making an educated guess. Whereas, deductive reasoning uses facts, definitions, and accepted properties and postulates in a logical order to draw appropriate conclusions. In mathematics, inductive reasoning is based on observations, while deductive reasoning is based on facts, and both are used by mathematicians to discover new proofs. If you proceed with facts and evidence, your deductive or inductive reasoning can quickly turn into an assumption, and that's what we typically try to avoid in life. A hypothesis, however, is a nice place to start. This is an idea that can be molded into factuality and follow the lines of deductive reasoning.